Okay guys, we are going to move into circles. So we're going to take a look at circumference and arc length. We'll do a deal with areas, all that stuff later. So let's take a look at some basic information you already know. If I have the center, let's call it P, that's my center of the circle. From the circle center to any point on the circumference of the circle is known as the radius. So let's call that point C, and we'll call this PC is radius. Okay, through the center, connecting on the other side all the way across is segment AB. We know that segment AB is diameter. And what we might not know is that we've got lots of what are called central angles. So if they come from the center of the circle and encompass an arc around the circle, it's called a central angle. So we know that angle APC is central angle. Okay, so we're going to use that a lot. Let's see. There's all kinds of arcs. So the arcs are the little chunks of the circumference that we're looking at. So it's not the whole sector, it's just the arc, just the piece that's a portion or a ratio of the entire circumference. And there's all kinds of circumferences or arcs. So let's take a look. An arc is a part of a circle. And you all have all kinds. So we have a semicircle. We already know a semicircle is a half a circle. So that would be this ACB. The semicircle goes halfway around the circle. We have a minor arc. And a minor arc is an arc less than a semicircle. So, for example, arc CB would be a minor arc because it's less than halfway. Arc AC would be another minor arc. And then we have what's called a major arc. And that's just an arc length that is greater than semicircle. And we can tell which arcs are being referenced by how they're named. So we need to know how they're named. So minor arcs name with two end points. So you're going to pick an arc that is less than a semicircle, and I'm going to use the two endpoints that make that arc. So I can have lots of different arcs. Arc AC. If I look at this piece of the circle right here, AC is less than half of it, and I name it with its endpoints. I'm going to work my way around the circle and easily identify all these arcs. So I've got arc AC, arc CE, and it's got an arc across it. I also have arc ED and arc DA. All of these could be named going the other direction as well. So we just need to pay attention to what they're referencing. Semicircles have 3 points. So we're looking at, I know a semicircle is chopped in half by the diameter, so I can name it arc DAC. And it tells you which direction I'm going by the naming of it, D to A to C. So I'm talking about this half of the circle. Or I could have this arc right here that's still connected with the diameter, and I would call it arc ACE. It's another half of a circle. And I also have this arc down below, which is CED. Again, naming all of them in the opposite direction rotation as well. But the two ends on the end point are the end of your arc, and then you need a third point in the middle. So if you don't have a third point, you need to drop a point in there so that you can name the arc. And then you have a major arc. Major arcs are also 3 points, but they're greater than a semicircle. So this is telling us circle O containing point A. So it needs to contain point A. It needs to be greater. If I stop at C, it's going to be the semicircle. So I need an arc that goes greater than a semicircle. So I can call it arc If I start at D includes A, so DAE. DAE is a major arc. I could also have arc CEA. What about A includes point A, so ACD would be another one. So lots of different ways you can do that. So you're going to try those next three, and then we're going to come back. Alright, there is some possible naming. You may have gone the opposite direction, so double check those. Just make sure you know minor arcs are 2, semicircles and major arcs are meant with 3 points. Let's talk about arc measures. So there's a difference between an arc length and an arc measure. When we're looking at measures, the measure of an arc is the same as the measure of its corresponding central angle. So if we take a look at this arc right here, RT, its central angle is 50 degrees. So the measure of RT would be 50 degrees. So the measure of RT is the same thing as the measure of the central angle, RST, which is equal to 50. If you're looking at a major arc, so you know a minor arc is corresponding central angle. The major arc just means, hey, the whole thing all the way around is 360. I've already used up 50, so I can find the measure of this major arc, RQT or TQR, by subtracting it from 360, this 50 from 360. So subtracted from. So you need to know how to find those minor and major arcs. And then the measure of a semicircle is halfway around your 360, so it's 180. That one we already know. So let's take a look at some special kind of arcs and finding some arc measures. So adjacent, remember that word from earlier. Adjacent means right next to. Well, let me get down here where you can actually see it. So if I have adjacent arcs, are arcs that have this, are arcs of the same circle. So I can't be an adjacent arc unless I'm in the same circle, that have exactly 1 point in common. So they're arcs that are right next to each other. So if I take a look at arc BC and arc CD, they're right next to each other and they share point C. So those are adjacent arcs. Let's find some arc measures. Now remember, the measure of an arc is corresponding to its central angle. So if I want the arc BC, that's this arc right here, the measure of BC, so I need to put an M in front of it because I know I'm dealing with an angle or a degree, is equal to the measure of angle BOC. Measure BOC. It's its corresponding central angle measure. So it is equal to 32 degrees. And arcs measures are in degrees because it matches your angle. So the measure of BD is equal to the measure of BC, arc BC. I want the measure of this whole arc BD. That means I need to take the measure of the little arc plus the measure of this other minor arc. Measure of BC plus the measure of arc CD, which is equal to 32 plus 58, which is equal to 90 degrees. ABC, ABC. ABC is created by the diameter, so the measure of arc ABC is equal to a semicircle's measure, which is 180 degrees. And the measure of just AB, so we're looking for just arc AB. So the measure of arc AB, so I don't know what's going on here. I don't have a measure, I don't have a central arc, but I do know that from ABC is the semicircle. If I subtract BC, I'll be left with what AB is. So it's equal to 180, the semicircle, minus the 32, that's part of BC, so it's 148 degrees. Okay? You should try the next few. Okay, so there are the answers for those. Let's take a look at circumference. We've all dealt with circumference already, so we're going to go pretty quickly. So my circumference, I'm going to abbreviate that, circumference of a circle is the area, is the distance around the circle. We know that. The number pi, pi is spelled P-I, and symbol of the pi symbol. is here's what we might not remember. We need to know this. Put a big star next to it, highlight it, do what you got to do. It's the ratio of circumference to the diameter. There's a relationship between the diameter and the circumference of a circle. It's the ratio between them, and that's how we end up getting similar circles. So the circumference we know already is, the circumference is pi d, d being diameter, or if I have the circumference, if I have the radius, I know the circumference is 2 pi r. So either one of these is interchangeable. If I know the diameter, I can divide it by 2 and then multiply by 2 and there. Or if I know the radius, I can double it and use the diameter formula. Either one works. So some of the properties of circles, though. Many properties of circles deal with ratios. It's all about ratios that stay the same no matter what the size the circle is. So we're going to take a look at those as we go. All circles are similar to each other. All circles are similar to each other because there is a similarity transformation. We know that's a translation followed by a dilation that maps one circle onto the other. So if I take a look at circle O and circle P, they're different sizes, but I can show that every single time, no matter what the circle, I can move it or translate it so that O and P are right on top of each other, and then I can dilate it or scale it up so that they're the same exact circle. So there is a similarity transformation for every single circle. Circles that are different sizes, but they share the same. So they're sitting on top of each other with the same center, but they're different sizes, they're different radii. If they're coplanar, meaning they're on the same plane, circles that have the same center are called concentric circles. And you see these a lot in art. You see them all over the place. Alright, let's take a look at our last bits of information. We found measures of arcs before. So we want to make sure that we understand the difference between measures and arc length. So let's apply some of the circle circumference stuff, and then we're going to take a look at length, which is different than the arc's measure. Okay, so we got a movie studio going on here, and it says a 2-foot wide circular track. So I know that the circular track is 2 feet wide. So the radius between the inside and the outside circle is an additional 2 feet. It is set up for a movie scene. The 2 rails of the track form concentric circles, so that means my center is shared. The radius of the inner circle is 8 feet. So I know from where the director here is standing to the first outside rail, or the inside rail, is 8. And then an additional 2 to get to the outside rail. How much farther does the wheel on the outer rail travel than the wheel on the inner? So if I'm looking at the inner circle, I can take a look all the way around the circumference to find out how far it travels each time it goes around. I know circumference is equal to 2 pi r. 2 pi, the radius of this inside circle is 8. So we end up with 16 pi. So I'm going to leave that for a minute, and I'm going to go take a look at the outer circle. The outer circle, again, the circumference is 2 pi r. And then I just have to substitute in what I know. 2 pi. The radius in this case, I have a center that's shared, so they're concentric. I go 8 plus another 2. So my radius for the outside is 10, which means that the circumference is 20 pi. If I want to figure out how much farther that outside wheel goes, I just take the difference. So 20 pi minus 16 pi is equal to 4 pi, which is approximately, in my calculator, 4 pi is 12.6 feet further. So every time that camera goes around, its outside wheel travels an extra 12, almost 13 feet further than the other wheel. Pause your video, try the next couple, come on back. All right, there are your answers for this. Let me know if you have any questions. And the last piece we want to look at is arc length. Measures are degrees. So measure, when it says arc measure, the measure of an arc is in degrees, has to do with its central angle. The length is a fraction or a ratio of the circumference. So there's a special formula that talks about, hey, the length is some sort of ratio of the whole length around. The measure is the degree dealing with its central angle. So the formula for the length of, let's call it arc AB, we're looking to find the length right here of that arc is equal to the ratio of its measure out of the full 360 times the entire circumference. Or, as we know, the measure of the AB, arc AB, out of the full 360 degrees possible. So the ratio of its degrees times the circumference. And it could be either radius or diameter. So let's take a look. I want to find the length of xy. So I need to find the length of xy. Watch your wording because it tells you which one you're going to use. So we know its central angle, its measure deals with its central angle, so we know it's 90 degrees. So I know that xy, the length of xy is equal to the measure of xy out of the full 360, so the proportion of the ratio of its measure, times the whole possible circumference. This case I'm using D because they gave me the diameter is 16. Substituting the pieces I know. I know the measure is 90 out of 360 times pi times 16, or 16D. 90 divided by, that cancels out, I end up with 1/4 times 16, which is 4, equals 4 pi inches. The length of that arc xy is 4 pi inches. And then we could approximate it if we want to, but we want to leave in terms of pi. So it wants to find the length of xpy. So I need to find this length. Since I'm dealing with length, I know xpy, which is a major arc, is equal to the measure of xpy out of the possible 360 times its diameter, or its circumference that I have. And I'm using r because that's all they gave me. I don't have a diameter. Substituting the pieces I know. Its measure is its corresponding central angle, so I know it's 240 degrees out of the possible 360 times 2 pi times 15. Do some mental math, do some calculator maths, reduce that, and I end up with 20 pi centimeters is the length of that arc. You've got one to try, and then we are done for today. Alrighty, let me know if you have any questions. I'll see you tomorrow.